Joining us on stage is Erik Ubels, who is the CIO for Deloitte in the Netherlands, where he was responsible for driving innovation with a unique combination of skills in IT, electronics, customer services, all combined together for the development of a new office for Deloitte in Amsterdam, which led to the first fully converged smart building in the world. And if you know anything about the Edge, you'll know it's received all sorts of wonderful plaudits, acclaims, and even got itself the name the world's smartest building, in addition to all sorts of other world firsts. Since then, Erik, from November the 1st in 2020, it's very specific here, has begun a new path into consulting in the smart building space, where he's supporting all of his clients with the things that they need to do to realize a smart building. So without further ado, please join me in a huge round of applause for Erik Ubels.
Thank you, Matthew. What an honor to be introduced by you. We know each other, I think, as long as we both have been working on smart buildings. So there must be like 12 years now or something like that, 10, 12 years. Anyway, nice to have you here. When I was asked by Bob, this is the third time I'm allowed to present here, and I thought, what am I going to talk about? And then the organization put in a title which says, what you do not know about smart buildings. And it was a placeholder. So about 2 weeks ago, they asked me, Erik, what is going to be your final title for your presentation? I had no clue. So I said, leave it there and I will figure out something. So now I have to come up with something you don't know about smart buildings, which I hopefully will. At least I will have some statements. People who know me know that I'm a guy who loves bold statements to trigger the discussion. So if you don't agree, even better. And let's talk over the break or whatever later today. Before we want to talk about smart buildings, what actually is a smart building? And we all have different views, but I think the views have changed quite rapidly. So when I got the opportunity to start working on the Edge building in Amsterdam for Deloitte, at that time I was responsible for IT, and I just got facilities under my control as well, and they told me to build a new building. And it needed to be smart, because the real investor basically told them, we're going to build you a smart building. And the first meeting I had with them, driving home, I thought, why is that called smart? It's just a very expensive thermostat, what they're talking about. What does it do for our people? And we decided to build that building in 2008, just at the point the crisis started. And you can imagine at that moment, after the plot was actually acquired by Deloitte for a lot of money, we had a kind of doubts about what are we going to do. So it needs to be sustainable for sure. It needs to be smart, whatever that meant. And at the same time, we want to make sure that when we come back from this economic crisis, we want to make sure we are the most attractive employer in the business. And that worked out quite well. But I had to learn with my team what smart was, and we had to drive the industry. At that time, we had a fight with every single engineering company, real estate company, software company, sensor company, because they didn't give us what we want. That situation has changed, but what also has changed a lot is that people are no longer talking about smart buildings just because of their energy efficiency, the sustainability, circularity, etc., etc. 2 years ago, after having an adventure with a real estate developer for 5 years, a company called Edge Technologies, developing a whole series of headquarters for large corporates, I decided to start on my own, and I put this quote here in the middle on LinkedIn. And in that time, I thought I was pretty smart by saying, a smart building is that in which the design, sustainability, technology provide for the health and well-being of humans. It comes seriously together. Pretty awesome, I thought. And now, only 2 years later, when I talk to customers, like last week, for example, in one single sentence, they mention that they want to do a new building, sometimes new, some redeveloped. And in the same sentence, they say, obviously, it needs to be sustainable, it needs to be smart, but it also needs to adhere to our new way of working after the COVID, people returning back to the office, but in complete different fashion, expecting complete different things from a building. So that's why we changed the statement, and now it includes the digital workplace and all the audiovisual. You heard this today already. So it's a different thing, which is good, I think. Things should evolve. So there's another thing, a statement I made before is that we need to take a very holistic view on a building. So everything you can imagine, from the building design, the materials, the passports that come with the materials, the BREEAM, the LEED, the WELL, the SMART certificates, the WIRED score, whatever kind of certificate it needs to get, whatever we need to look at it from a very holistic perspective. It's not just about the building, it's not about the IoT sensors or the data, but it's how do we make sure that the building provides the best place to go to. I don't even use the word work anymore, because many times the building is just a meeting place to spend time with your customers. And I believe we still have a huge amount of work to do, because I think that when I meet with principal architects who make the most amazing designs of the building, that's what they want. They want to have recognition for the building. It should fit the environment, the city, or wherever it's built. But I do believe that the principal architects, the big names in this industry, still do not take their responsibility once the design of the building is done and it goes into engineering. So where are they when we talk about the climate systems, the actual sustainability of the building, et cetera, et cetera? I think they should take that responsibility, because their name is put on that building, on the design, and they should take much more effort in making sure the building is sustainable to the extent possible. And that's still not done today. If you're in this industry, you know that this is the most reluctant industry to move forward. It's at least 10 years slower than the process industry in adopting new technology. And obviously that's because it's very traditional, it's very fragmented. Don't believe me for it. There's a free report on the World Economic Forum website that tells you what's going on in this industry. This is also the only industry which has a production loss for 75 years in a row. That means every consecutive year we are producing less square meters of buildings with the same amount of people, or the way you want to look at it, which is not good news, given the fact that we still need a lot of new buildings in the world, and that the buildings are producing such a tremendous amount of CO2 pollution. I also think IT people need to take a different view, and that is that they need to understand that everything in the building, by definition, is IT, whether they like it or not. Doesn't mean that they have application responsibility on a day-to-day basis, no. But you cannot say a building access system is facilities, because a building access system today is IP. You cannot say the camera security system is somebody else's. And this is true for every piece of technology you put in a building. It's IP enabled, it's IT, it needs to be secure, it needs to provide data. And IT people need to take that role seriously. Facility managers need to drive the full integration. I think I'll come back to that in a moment, but what I mean is you can no longer say, somebody built the building, used the BIM model, nice, thank you, now the building is delivered to me, now I'm going to operate it, and I got my facility management system. And no, the BIM should become part of the life cycle of managing that building. So it should go along with the building. That means the BIM model needs to talk to the digital twin of the building. The digital twin needs to talk to the facility management solution, to the smart building platform where you take your data from and you do your analysis. And then, of course, security and safety people also need to realize that all of their stuff is converging. You cannot longer separate a camera system from your security system, like building access, or from Bluetooth localization, or all of those things. It comes together, and there is a lot of vertical integration taking place in that industry. Companies like Genetec, you may have heard of those, who basically give you one single platform for where your cameras are, your building access is, your burglar systems are, your fire extension systems, your evacuation. It all comes together, and it moves from physical, logical, to from physical access like cards to logical access. So it integrates with directory services, most well known like Active Directory or Azure Active Directory from people like Microsoft. So that being said, let's look at the building and let's start with a statement. Smart building, life gets easier, costs are going down, and demand is a given. And I'm sure you don't agree with that. Why do I say that? Life gets easier. Of course, the amount of stuff we put in the building makes the building by definition more complex than the building was so far, but because this is all moving to IP enabled and power over Ethernet and these kind of technologies, that makes life a little bit easier. More and more people start to understand that the IP network is not just the corporate network, but it's the network for the building and everything you do in the building. I'll come back to that. Costs are going down. That's the most controversial one to make this afternoon, I guess, because the prices in this industry are rising like crazy, as never before. If you're in the build industry, if you're buying wood or aluminium or anything else, it is just insane. However, this is of course in the longer term perspective. Okay? So yes, at the moment, due to the war in Ukraine and all kind of other reasons, stuff is very expensive, but look at it in the long run, and I will come back to that as well. So I will explain why I think it gets easier. I will explain why costs are going down. I got examples, real life examples for you, and obviously the demand is a given, and I will come back to that as well. How I look at the building at the moment, or buildings, that's basically the whole of smart buildings, for me, is a counterpoint between two themes. A stunning variety in individual particulars. Every single building is different. That's why I hear all the time from everybody, if I say we should do things easier, make life easier for people, yes, but every building is different, which is true. Go out in the street here, you don't see a single building which is the same as the one next to it. But in reality, when you look inside the building, into power distribution, building management systems, elevators, sensor networks, HVAC, all of that stuff, by all means, is pretty much the same. There are thousands of brands out there, but the building management system, it's basically a computer that runs some BACnet stuff. I hope there's nobody in the BACnet space, or KNX or whatever, doesn't matter. So I think when you take a little bit of a distance and look at buildings, you can see that they're pretty much the same, even though the package is different in every situation. Let's look about life gets easier. What do I mean with life gets easier? Sometimes you talk to people, say, Erik, we don't want all this digital stuff. We don't want the data, we don't want the sensors, we don't want this, etc., etc. Okay, because they are afraid, they don't know about it, whatever the reason is. I got bad news for those people. You cannot buy it without. It simply does not exist. Try to buy the latest air handling unit from whatever brand, it doesn't matter. It does come with a controller board, it does come with connectivity, it does have a whole bunch of sensors, it allows you to take the data from that device. Maybe it doesn't do predictive maintenance based on the data yet, but it's simply there. The thing is digitalized by itself. This is true for the light infrastructure, this is true for power. Look at power. Only a couple of years ago, power was nothing else than basically taking power from the grid and distribute it. Now power includes solar panels, electric charging, battery system, smart grids to balance all the power between whatever you have available in the grid and what comes from charging cars, etc., etc. So it's digitalizing like crazy, whether you want it or not. This is also true for the building management systems. I got a simple example here from a Dutch company called Priva, but these guys are buying the sensor companies and other companies to have a complete offering. And Schneider is doing the same. Schneider bought heavily into Planon and some of those other companies, so you see this vertical integration. On the right side, you got the famous example of the ThyssenKrupp elevators. If you never looked at it, look at their videos on YouTube called ThyssenKrupp Max, and you will be completely surprised the amount of the data they take out from the elevators. It's fine that you buy this and don't want to use this, that's a choice, but by heavens, it's there. You cannot buy it without. So the digital stuff is there, the data is there. And then obviously the building gets integrated to a level we've never seen before. So let's look at that. So all the different systems here are basically power, telephony, elevators, lights, sensors, fire alarm, whatever you have in a building, security, and all of that stuff is now talking IP. It's connected to your IP network. Whether that's wireless or wired doesn't matter, but it's there, okay? So companies now looking into integrating the whole IP backbone in a building, converged IP backbone. I did this in the Edge building in 2010. People told me I was crazy, I got it wrong. The good news is now Cisco and Schneider announced a big joint venture on doing this, so probably takes 10 years before I'm right, which is fine. I always have to tell my wife, 10 years ago I told you this and now it turns out I was right. So, but one IP, converged IP network. Why? Because you all want the same IP, you want the same connectivity, you want the same level of security. A lot of people say, oh, I don't want to do this because I don't trust the building. Well, that's exactly the reason you should do it. Because if you trust your IP network, your corporate IP network, then I would definitely put your building IP network behind it to make sure it has the same level of security. And the other thing is, of course, look at it from a more principle standpoint of view. One IP network saves you cable, saves you electronics, saves you waste, saves you power, saves you energy, saves you effort. So I think we have an obligation to the people who are living on this earth beyond my day, what do you say, my last day? Anyway, what I'm trying to say, there's a lot of reasons to do it, there's a lot of material out there, and it makes a lot of sense and makes life a lot easier. Then, of course, all the devices, all the stuff. You can now get decent power over Ethernet capabilities up to 90 watts. Initially, when I did the edge building, it was 30 watts, so we could only run a certain amount of devices on power over Ethernet. They're now working on 200 watt power over Ethernet. That means you can put a lot of different pieces of technology on the power over Ethernet network, and you have just an example of devices. But this is building access systems, Wi-Fi access points, intercoms. This is always the ultimate. Yesterday I was in a building and I took a picture from the reception desk and I showed it to my customer. I said, have you ever looked behind the reception desk? There are 7 different intercoms. And you wonder why the receptionist does not respond on time, because at 9 o'clock in the morning they all ring at the same time, because there's somebody at the loading station, there's somebody at the parking garage, in the bike garage, in the elevator, whatever. That's ridiculous. All of this stuff is now available, fully IP enabled. You can even have it directly talk to Microsoft Teams if you want, or at least IP SIP enabled. So life gets easier, and this stuff is getting cheaper like crazy every single day. Okay? Where you would pay a couple of €1,000 for an intercom only a few years ago, now you can buy any brand between 500 to 700 euros, and you can have a proliferation of choice. So that's what I mean. It gets cheaper, it gets easier. The other nice thing is Wi-Fi networks, both Cisco and Aruba now deliver also Wi-Fi with Bluetooth, obviously, but also with Zigbee and Ocean capability. That means the same Wi-Fi network becomes your IoT gateway network, if you like. So if you want to add sensors later on for whatever reason, you don't have to install different technology, you're just using the Wi-Fi network. Costs are going down. This is probably the big secret, and a lot of people don't believe me. So I am going to show you numbers from real life buildings in operation. This is not a, theoretical exercise or something like that. This is up and running, working buildings. This is in the US. It's not a huge building, but it's a building. Why do I say it's not used? Because you can imagine if the building becomes bigger, the numbers even become better. Because you still need always a core piece of technology in a building, whatever the size is. You need firewalls, you need intrusion detection, you need core switches, etc., etc. This building basically shows you that if you move from a traditional control system to a totally IP-enabled system, you're going to save about $239,000 on that building. Again, it's only 25,000 square meters, so it's not a huge building. But nevertheless, it's a building, it works. There's a little, to be totally honest with you, there's a little bit of a shift if you look at the graph, that you can actually see that your operational costs are going up slightly. Okay, so the cost you will have on an ongoing basis are slightly higher than the initial investment. Nevertheless, it's still cheaper. Now the next one. This one is even more expensive. This is more interesting, I think. So when you look at this, again, this is done by Arup. This is going to be published in a much bigger fashion than what I have here today, but they're going to demonstrate much more detail. But what happens here is, look at an existing building, traditional control, in a pre-pandemic plan. That means everybody has his own little desk, booth, or whatever it is. Then look into a post-pandemic plan. That means, which we see in a lot of buildings, there are less workplaces actually, but there's more different kind of meeting rooms, activity-based working. People have more choice, so that means more square meter per person, but less people in the building. So, which is good news for the people who are in the building industry. The demand for building is not going down that rapidly as expected for a while in the COVID period. Now here, you actually see an increase in cost. So where does my statement come from? And that I have to point, can I point with this thing? Here. Danger, okay? Oh, here. Can you see that? No. Okay, so let me take you with this. Here you see a price difference between 4.5 and, I'm too big, I'm standing in front of it. 4.5 and 8% increase. So everybody says, hey, that's higher in price. That is true, but there's one huge difference. Where does this come from? In this case, we have a whole proliferation of sensors. This is using a multi-sensor capability, and this is a traditional control on the wall. So this is the thermostat you typically see on the wall, you know, the one that you can change the temperature, but it actually doesn't change the temperature, that one. And sometimes it has a CO2 measurement in there to drive the fan. So this is traditional wall-mounted control, and this is using the latest and greatest multi-sensor, which measures light temperature, fan control, response to daylight, localization with Bluetooth, measures sound, humidity, and does people counting, and provide Bluetooth. So based on this, if you would take that out, so you would really have a one-to-one comparison, then we would not have the 4.5% increase. It would be actually lower. The 8% increase is if you still put the wall-mounted thermostat on the wall. That is something where you can make money with very easily. In every building I do, I have this debate. Because the engineering companies still want to put the all wall-mounted Schneider, Honeywell, Siemens, whatever the thing is, on the wall, and there's no reason. Because the multi-sensors you can buy can provide exactly the same data for your building management system. Okay, demand is a given. Well, first of all, because there's a lot of research done by companies like Memory, Guidehouse, there's a whole bunch of those. Interesting thing, and something we should take away to home, is that 98% of C-level people in the world, that is, you know, CEOs, CIOs, CTO, whatever, directors and managers, 98% of them want to invest in a smart building. That's tremendous good news, everybody. The bad news is, 48% of them, exactly half of them, stop the effort after the first time they meet a consultant. That's our fault. Why? Because we tell them it's going to be expensive and complex. And that's the biggest message I want to give to you today. It is not true. If you really start thinking upfront and you are not driving, I don't know, is there anyone out of this installation industry for smart buildings, for buildings, not audiovisual? DDC controllers? Okay, this industry at large is using something which is called DDC controllers that are overpriced PLCs. That's not IP-enabled technology. If you put IP-enabled technology in there, you save a lot of money. If you put in a multi-sensor, I just demonstrated that to you, and a lot of PoE power device, you save a lot of money. So the good news is, its price is going down, and there's a huge demand. Unfortunately, a lot of these people who are actually in charge to make the call are basically scared away by us, saying, oh, if you want to do a smart building, you need all different kind of sensors, you have a system integration problem, you have a data problem, etc., etc. Who's going to buy something if you say, if you want to do this, it's going to give you trouble? You go to a second-hand car dealer and say, this car is a wreck, it won't run. Would you buy it? No, of course not. So, the demand is there, huge demand, which is the good news. There's also a couple of other things, especially number 3 on this list, and that is regulation and government. No time ever before than now, here in Europe, we got the regulators, the European Union, your governments, and everything behind us, because they demand Paris-proof buildings. 76% of buildings does not comply with Paris-proof. So that means every building needs to be touched. Retrofit doesn't matter. Do IP enable, do it wireless, whatever you do, but you can do it. So that's good news. So the demand is also a given. And then, oh yeah, there's one thing I wanted to do, and I still have time, and let's talk about digital twin. Everybody in this industry talks about digital twin, agree? It's overhyped like crazy. And yet there's nothing out there that I consider digital twin. And I'm going to attempt in 5 minutes to explain the difference between a digital twin, as you will see here the next couple of days on the trade show, because everybody suddenly has a digital twin, and the real thing. So, when you integrate all the systems in the building, you do a lot of API integration, agree? And in the building, most of the time, these are API to API connections. That I took this example. Let's say I got a Bluetooth localization capability in my building, and I want to connect it to the camera system. Your face won't be recognized if you're not in the area. The door won't open if you're not in the area. Whatever reason you have to do that. The building access system is connected to that. Your mobile phone is connected to it. The rest is a little bit bullshit. It was just to make a picture. So, but what I'm trying to say here is the traditional way is we've got a lot of different systems, and we're going to use APIs to connect everything with each other. A lot of API to API integration. That's the typical way it's done. At a certain point, the good news is we get a lot of data from all of those things, and we put this in a database model. Typically a relational database model. I'm sure you've all seen those things with tables and rows and normalized, etc., etc. And then if we're lucky, we got a digital twin. So now we go to the trade floor, and somebody is spinning around your building with a mouse. And you get impressed. Wow, I can spin around the building with a mouse. Nobody needs that in real life, but nevertheless, it makes a good commercial story. In reality, then they take you into the building, maybe to the floor plan. And on the floor plan, they will show you so-called heat maps. Temperature, humidity, CO2 levels, number of people, room is occupied, wherever it is. And if you take a closer look at that, it looks something like that. So you see the meeting room, and you see the lux level, you see the CO2 levels, etc., etc. In reality, nothing else happened than having a picture of the building, irrelevant how fancy it is, and it took data from your database and it plotted it on the picture. There's no relationship whatsoever between the data. The temperature has no clue about humidity. The CO2 level has no clue about the people in the building. It is just plotting data on a fancy design, probably in 3D in a building. That's not a digital twin. When I started my career after school at electronics, I started working for Philips Electronics. We built a lot of the machines ourselves. We were already doing this 40 years ago. We called it human-machine interface, not digital twin. So let's go to the next picture. And at the risk that I'm losing you, but at least I did an attempt. And the most important thing I want you to get out of this is that please start to read into what digital twin is, because there's not going to be a smart building in the future, smart industry, smart city, smart I don't get where, whatever, but it will have a real digital twin. And what does it mean to have a real digital twin? In a real digital twin, they use a language, they call it taxonomy, that's just to scare you, okay? But that is basically describing the relationship between all those things. You know, hopefully from class, from science class, that there's a pretty clear relationship between temperature and humidity. They go hand in hand. Intra first, I think, something like that, but that doesn't matter. If I put more people in the room, the CO2 level goes up, okay, et cetera, et cetera. There's a lot of that kind of rules by nature, by science. So what we're trying to do is model everything in the building. The building itself, the spaces, like the building has a size, the building has a location, the building has a number of floors, the floors have rooms, the rooms have capacity, the room have a temperature, the room have whatever they may have. And it's all being used to describe it in a language. That is the real estate core language, invented by the John Coppin University in Sweden. Please look it up, real estate core. And what they then do, they put it in nice graphs, Microsoft Digital Twin for Azure or whatever, but that's one of them. And they put this whole model in a building. And then instead of doing API to API integration, all of the different systems in the building would actually talk to a computer model, which is running in an active mode on the cloud, and actually drive everything from this model. So the model gets data, the model responds to whatever other part of the device it needs to respond to. With that, you get a different way of getting the data. You get the sensors, you still have the data, but you don't put it in a relational database model, you put it in a data lake. That's really a lake. You just throw everything in a lake unorganized. Cloud computing is so fast that you do no longer have to organize it up front. You only organize it by querying it at the time you need it. And another advantage of the digital twin is that I can model a building, including the BIM model, and completely simulate the building before I have ever built it, which is good. Once I have it up and running and it's working, I can change things and test it before I change it. Okay? I hope this comes across a little bit. I have a few seconds. There's other good news for us in the story of it gets easier. There was a lot of fight in the industry about the BIM model, who wants to be the digital twin, and the common data model, and the guys who do brick and haystack and all of those. At this moment in time, the reality is that these people are coming together, and they finally start to understand that the BIM model is something we use to design the building, to engineer the building, hopefully to build the building, and it gets into life cycle of managing the building. Brick and haystack is being used for the tagging and notation of the building management system. The digital twin, I just tried to explain, I hope it came across. But you still need, in some cases, a relational data model to actually use for reporting or whatever reason. And therefore you have the common data model. So these four together actually and finally build the stack we need. And with that, I would like to finish my presentation and thank you for your time.